So one way of identifying parallel lines and perpendicular lines is by creating a graph. And if you created a graph, you would identify parallel lines because what's the definition of parallel? They don't touch. They never intersect. Lines that never intersect. If you extended them forever in both directions, they would never meet up. Parallel lines would never intersect. And you would identify perpendicular lines if you graphed them. How would you know that two lines that you graphed, a picture of them, how would you know that those two lines on your graph are perpendicular? Sam, what would you?
If they both have an angle compared to each other.
What kind of angle?
A not straight angle.
Joseph?
A 90-degree angle.
Perfect. They intersect, but more than intersect, I-N-T-E-R-S-E-C-T, more than intersect, they intersect at 90 degrees. They have to be like perpendicular. This line and this line are perpendicular because they intersect at 90 degrees. 90 degrees. The key is parallel lines never intersect. Perpendicular lines intersect at 90 degrees. But there are a whole bunch of other types of intersections, but the perfect intersection of 90 degrees is perpendicular. It has its own name. Everything else is just lumped together as intersecting. So, let's think about this. We're going to draw a graph. And it needs to be pretty good. Doesn't have to be perfect, but it needs to be pretty good. Doesn't have to be perfect, but it needs to be pretty good. And we are going to plot these lines. Y equals 3/4 x plus 2. And y equals 6/8 x minus 4. Yep, thank you. Okay, so we're going to plot those two lines. My first one, I go up 2. And from that point, I'm going to go up 1, 2, 3 over 1, 2, 3, 4. I want to do it again, but I'm going to go down 3 and backward 4. Then we're going to plot the second line. This one starts at -4. And from there, I'm going to go up 6 and over 8. But my graph isn't that big. I mean, I can extend it. I can go up 1, 2, 3, 4, 5, 6, and over 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? I have to be a little creative. It's off the graph. That's okay. You can make it work. Or what else could you do, Henry?
Couldn't you have the fraction?
You mean simplify your fraction?
Yeah.
Because this is your slope right here, and 6/8 could be simplified to what? To what?
3/4.
It could simplify. You could simplify 6/8. 6/8, since they're both even, can simplify to up 1, 2, 3 over 1, 2, 3, 4. What do you notice about these two lines? Whoa. No one said the right answer.
They're parallel.
They're parallel.
Yeah, only they're perpendicular.
They're parallel.
Yeah.
The blue lines are not perpendicular either.
They're weird. Why are they different? Is that just because
Parallel lines. What do they have in common? What's the same for these parallel lines? What do they, Serenity? Have the same slope. Parallel lines have the same slope. If I said, hey, are those two lines parallel? And I gave you the equations, you could draw a graph, plot the points. Or you could look at those two equations and you could say, well, Mrs. Long, yes, they are parallel. And I know that they're parallel because the slopes are exactly the same. And if the slopes are exactly the same, even though 3/4 are different numbers than 6/8, right? Even though those are different numbers, when you simplify those fractions, it creates the same slope. So now let's do perpendicular. Let's do our graph on this side for perpendicular. Again, it doesn't have to be perfect, but it needs to be a decent graph. 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Got a little overzealous. That's okay. Because I'm going to give you two lines, and you are going to tell me, are they parallel? Are they perpendicular? Well, we know how to do parallel right now because parallel lines have the same slope. I could graph it, but I could just look at their slopes and figure it out. So I'm going to give you two equations. Y equals 5/3 x plus 1. Hold on. Okay, let's do that first one. y equals 5/3 x plus 1. So if I was going to graph that, I would start at 1. And from there I would go up 5. 1, 2, 3, 4, 5. And over 3. 1, 2, 3. And I'd do the opposite, which is down 1, 2, 3, 4, 5. And over 3. 1, 2, 3. So I want you to think about, before we start anything, take your pencil after you have this, or your pen, after you have this drawn. What would a perpendicular line, make your pen or pencil perpendicular. If this is your line right here, right? What would you do for perpendicular? This line right here, the slope is 5/3, right? Where would it go? Tell me what to do with this pen to make it perpendicular. I'm going to move it up like this. That's perpendicular?
No.
What do I do, Jacob? Okay, I'm going to rotate. What does rotate mean?
Turn.
Turn it. Okay, so I'm going to go like
290 degrees.
this. Is that perpendicular?
No.
So tell me when to stop.
Go.
Stop.
She's off the center.
No, don't stop. Keep
Go
going.
on the dot.
Stop. Stop.
It's not
There.
really.
Yeah, there.
Keep going.
No, Jacob, you
No,
gotta
stop.
Jacob.
Is that too much?
Yes.
Stop.
You're blind.
Okay. So, listen.
Jacob, that is on the line.
I want you to think about this while we figure this out, because we're going to plot this next one. But I want you to think about, we just talked about how parallel lines have the same slope. So we're going to be dealing with slope probably.
Would it be 3/5?
So think about what you think the slope of this line, what characteristics does this line, what are the characteristics of this slope? What are the characteristics? So just think about the characteristics. We'll get there, but let's now graph this. Can I graph this the way that it is? Because it's not in slope-intercept form. Let's get it in slope-intercept form. Minus 3x, minus 3x. Do you agree? Yes, no, maybe so? Okay. Then I'm left with 5y equals negative 3x minus 10. Am I done?
Huh.
Divide by 5. Y equals negative 3/5 x. And what's this?
-2.
Minus 2. So if I was going to graph this, I'd go negative 2. And my slope is negative 3 over 5, meaning down 3, positive 5. And up 3, negative 5. Now again, I'm not a robot, so my lines aren't perfect. But those are not parallel, those are perpendicular. So, I had some good guesses. I heard someone predict that the slope would be, instead of 5 over 3, which was our first slope, I heard someone predict 3 over 5. It's close. So the slope, perpendicular slope, Perpendicular slopes have what? How could you describe the relationship between these slopes?
They intersect at a 90 degree angle.
Joseph, what do you think?
They intersected in 90 degree angle.
How could you describe these slopes? The relationship between 5/3
They're
and
opposites.
-3/5. Okay, opposite because what?
Because the rest is negative.
Because one is
Negative.
positive and one is negative. So they're opposites. One's positive and one's negative. Have opposite.
Kind of like flip.
What's the word for flipped? Opposite. Reciprocal. REC. Oh my gosh, you guys. That was a terrible spelling job.
Good thing we don't take spelling.
I know, right?
There.
That's what happens when I talk and write different words. Reciprocal. CAL. Reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. One's positive, one's negative. One's positive, one's negative. I want to do a few examples on page 56 really quickly to show you what homework's going to look like. So go back to table of contents and 56, put practice, please.
Some people try to do.
Okay, here we go. Your homework tonight will look like this. It's a combo of today and Monday. I'm going to tell you write the slope-intercept equation for a line. Let's do perpendicular. To y equals 3x minus 8. Passing through -4. So tonight, your homework will ask you a question like this. It will say, write the slope-intercept equation for a line that is perpendicular to y equals 3x minus 8. Passing through the ordered pair 3, -4. So here's your hint. Here's your hint. This is a combination of what we just learned today and what we learned on Monday. So again, you could be turning pages in your notebook right now. This is a combination of what we just learned today. Today we learned the perpendicular or parallel part. And what we learned one lesson before. What was our lesson before today's about? What was it about?
Point
slope form.
Point slope form. That sounds intriguing. I wonder what you're required to have in order to use point
Oh,
slope.
there's a point form.
There's a point here and a slope.
If I was going to use point slope form, I'd probably need to have
Point.
a point and a
Slope.
Are you sure?
Slope
Yes.
is in the equation.
Okay, so I hear some good thoughts. I hear slope is in the equation. Where?
It's in that y equals 3x.
It's in this equation right here, right? Your slope is actually 3. Ooh, I like that. Is 3 over 1.
I did a good.
You want a cookie or something?
And we have a point. So when you are given a point and a slope, you can use point slope form. Do you agree? Y minus y1 equals m x minus x1. That's what we learned in our previous lesson. Now, all I have to do is, what are my 3 steps for point slope form? Substitute, simplify, solve for y. So, substitute, simplify, solve for y. Substitute, simplify, solve for y. Substitute, first step. Y. This stays the same because there's no subscript. Minus. But instead of y1, what do I substitute? -4, making this become +4. Equals.
M.
Oh, what?
3 over 1.
Ooh.
3 over
Ooh, what? Why, Sasha, are you saying -1 over 3? Because what does it say up here?
Yeah, the opposite. Oh, yeah, it's the opposite of 1 because we have to make it perpendicular.
Oh, yeah, it's
It's the opposite reciprocal because we want it to be perpendicular. If this said parallel, we could put 3. But it says perpendicular. Parallel lines have the same slope, but perpendicular lines are opposite reciprocals. Parentheses. X minus 3. First step, substitute. Second step, simplify. Here we go, simplify. Y plus 4 cannot be simplified. Equals -1/3 times x is
-1/3 x.
beautiful. -1/3 times -3,
1.
positive 1 plus 1. Substitute, check. Simplify,
Check.
check. What's step 3?
Solve for x.
Solve for
Y.
y. -4 minus 4.
So then you just got y equals
Minus 3.
-3.
And I know that this line and this line are perpendicular. And how do I know that they're perpendicular? Because their slopes are Opposite.
Reciprocals.
Positive, negative. Reciprocals.
Yeah.
Numerator and denominator switch places. If it said parallel, you use the same slope. 10.